These are the answers to review for quiz 334, pages 3 and 4. So for the first one, they want us to find relative extrema, inflection points, interval, and convergence. I was kind of in the middle of this and my phone died, so we'll just kind of walk through it again. We're going to take the derivative of this, which gives us that. We're going to set it equal to 0. While I set it equal to 0, I'll pull a 6 out. Then I'm going to factor what's left over, and that gives me critical point numbers of 2 and -1. So then I put -1 and 2 down on the number line. I'm testing the first derivative. So I pick something like, say, -10, put it into the derivative. I get 600 plus 60 minus 12. That's a positive. So that means my function g is increasing at that point. Pick something like 0 here, put it in, I get -12. So that means I have a negative derivative. My function is decreasing. Pick something bigger than 2, say 10, put it in, I'm going to get a positive. It means my function is increasing. So as far as relative extrema goes, since the derivative switched from positive to negative, we're going from increasing to decreasing. -1 is a relative maximum. And because the derivative switched from negative to positive, we're going from decreasing to increasing. +2 is a relative minimum. Right. Now, as far as anything beyond that, we have to find the second derivative, which was 12x minus 6. Set that equal to 0. I got x equal to 1/2. When I test on either side of 1/2, I had a negative second derivative less than 1/2. So that means my function is concave down. And a positive second derivative greater than 1/2, that means my function is concave up. So where are we concave? We are concave down from -infinity to 1/2. And we are concave up from 1/2 to positive infinity. And because we switch concavity, that means that x equal 1/2. That's our inflection point. Okay. So that one's pretty straightforward. Hopefully that felt pretty easy. We come to number 6, and there's a little more to it. We're only talking about from 0 to infinity, so we won't include 0, so I don't have to worry about that asymptote or anything that would make this negative. So we're only looking in there. So first derivative, I'm going to do quotient rule. So we're going to take the bottom. So I'm going to write that as x to the 1/2 times the derivative of the top, which is 1, minus the top, x plus 1, times the derivative of the bottom, which is 1/2 x to the -1/2, over the bottom squared, which is x. Now there's a whole lot of junk going on here, right? And trying to get this equal to 0 and seeing where this might equal 0 is going to be a little nasty, but we'll do our best. First thing we can do is if we set it equal to 0, I can kind of forget about the bottom. Because if we were to, since x can't equal 0 anyway, we don't have to worry about what makes the bottom 0. If I multiply through by this, I'll have just the top. In other words, I'm really only interested in what makes the top equal to 0. I'm going to rewrite this part here. I'm going to put x plus 1 on the top, 2 on the bottom. This drops to the bottom with it. And maybe it might be better for me to put that as a square root as well. All right. Now, what I like to do here, you can do a couple different things. But what I like to do is I like to swing this part over, make this x plus 1 over 2 squared root of x equal to square root of x. And then I'm going to multiply by that bottom. And I'm going to get x plus 1 equal to 2 times square root of x times square root of x, which is x. If you subtract x now, you get x equal 1. So it's kind of a, again, kind of a clever way to do that problem there. All right. What does that mean? Well, let's check out our first derivative test. If I pick something less than 1 and I put it into the derivative, say I put 1/2 or something in there, or even 1/4, square root of 1/4 is 1/2, minus, we end up with 5/4, and then this is going to be 1. So 1/2 minus 5/4 is a negative. It means our function is decreasing at that point. If I pick something bigger than 1, that one's a little bit easier. Say I put 9 in here, I'm going to get 3, and then I'm going to have 10 divided by 6. So 3 minus 10/6 is a positive. We're increasing at that point. Okay, so we're going to have a relative minimum at x equal 1, because that's where our derivative switches from negative to positive. Now, as far as the inflection points, now this becomes a little bit trickier. One thing we could do, and this is, instead of trying to tackle this derivative, which would be very nasty, what if I go back to the original and I just rewrite it real quick? Write this as x divided by square root of x, which would be x to the 1/2, plus 1 over square root of x, which would be x to the negative 1/2. All right? And then I'm going to just kind of tackle it through this way. So my derivative would be 1/2 x to the negative 1/2 minus 1/2 x to the negative 3/2. And then my second derivative will be negative 1/4 x to the negative 3/2 plus 3/4 times x to the negative 5/2. All right. Now, again, you might think, well, how does that make life any easier? And maybe in some ways it doesn't. But I think what you're going to see is a little bit of a clever trick. And you're saying, God, please tell me this is not on the AP. And no, this goes a little bit beyond what you'd have to do on an AP. Here's what we're going to do. We're going to set this equal to 0. All right. So here's all of our junk here. I'm going to add this part over. Anything that's negative, I like to kind of swing over, so I'm working with just positive things, right? Equals 3/4 x to the negative 5/2. And then what I'm going to do is I'm going to push this down. So it's going to be 1 over 4 x to the 3/2. And I'm going to push this one down 3 over 4 x to the 5/2. And then I'm going to multiply by 4x to the 5/2, and you'll see why in a second. So I'm multiplying both sides by this 4x to the 5/2, which is going to cancel completely here. Give me just 3. If I do it here, the 4's will cancel, and I'll have x to the 5/2 over x to the 3/2. 5/2 minus 3/2 is 2/2, or x to the first. Again, that's kind of a slick thing that I could kind of see ahead of time because I've done these things before, and it's almost impossible to see if you've never done something like this before. So what I just want you to do is to kind of look and say, all right, I followed the algebra, I see what you did. Maybe I wouldn't have done it myself, Mr. O, but I can kind of see what's happening there. Now we can test on either side of that. So if we put 1 into the second derivative, we get negative 1/4 plus 3/4. That's a positive. So we're concave up at that point. And if we pick something bigger than 3 and put it in there, let's say 9. I'm going to get 1/6 here minus, and this would be 1/54. It's going to be looks like it's going to be a positive as well. Might want to check that. I'm working without a calculator here. I think that might be correct. But if for some reason it wasn't, then we would want to kind of revisit that. All right. At any rate, oh, wait a minute. I think I was looking at the wrong one. My apologies. This is going to be a negative. Concave down. I thought that was probably true. All right. What are intervals of concavity? We're concave up from 0 to 3. We're concave down from 3 to infinity. Where's our point of inflection? That would be at x equals 3. All right. So that's pages 3 and 4.